the modern guide to the digitalization of infrastructure. I will just explain briefly how we want to set the webinar. I will be making a very short presentation, and then we will move to the different authors. They will be making a very short presentation, 5 minutes, about the key findings in their chapters. And then we will open a Q&A, questions and answer session. So you will have a few minutes to pose your questions. And then we will conclude with some remarks from Matthias Finger, the co-editor of the book. This is a book that has 15 authors and 11 chapters, covering basically all the main infrastructure-based industries. So all the main transport industries, electricity, postal services, water. It is based mostly on the works of DIGEX, which is the acronym from this Digitalization Infrastructure group of experts that was established 3 years ago in Florence. All the authors are part of this group that was set to discuss and to find common themes in the digitalization of infrastructure. We had different meetings. We started with physical meetings, then the pandemic arrived, and we've been meeting mostly online. And the book is basically the result of the works of this working group. I just want to go very briefly through some of the key findings of the both the DIGEX and working group and the individual work of the authors that has been reflected in the book. The book, as the title explains, is about the digitalization of infrastructure. We understand digitalization as a process that basically entails the conversion of information into a series of digits, which enables the automated processing of such information. Now, this is a general definition for all kind of digitalization processes, but specifically for infrastructure, it entails some very specific challenges and results. First of all, we have identified that there is, from a technical point of view, 3 elements in terms of data generation through a set of sensors, data transmission through a set of technologies like 5G, Internet of Things, edge computing, and then data management through algorithms, machine learning. Most of these technologies, as Professor Knips will explain, are general purpose technologies that apply even beyond infrastructure-based industries, but that definitely pose the same kind of challenges and the same transformations in the infrastructure-based industries. At the end of the day, it is about automating processes and creating new efficiencies in the management of the infrastructure. But at the same time, it allows new interactions between the different players in each sector, which at the end of the day might trigger very deep transformations in market structure. So it's just a process that started even decades ago, very slowly, with the use of some technologies that gradually, and with the introduction of the internet, algorithms, computers, etc., has over the last years really exploded. So in terms of results, we can identify 4 or 5 key elements of how digitalization is transforming infrastructure. First of all, we can identify that digitalization reduces the cost in design, construction, maintenance, and consumption metering in the different infrastructures. And this is something that can be achieved basically pretty much individually by each infrastructure manager. So if you go through the chapters, you will identify a lot of specific analysis for each industry, for each piece of infrastructure, on what the reduction in terms of cost in design, construction, very particularly maintenance, what these cost reductions are. I think this is one of the most interesting parts of the book. It's a literature review analyzing different studies. And it's a common theme across all infrastructures that there are very significant cost reductions in the management of the introduction. So this is the first positive element in terms of the impact of digitalization. But it's not only about the construction maintenance of the infrastructure. but the transformation runs deeper into the management of the infrastructure. And as we are identifying, digitalization allows a more active and dynamic management of the infrastructure, of all kinds of infrastructures. So basically what we have identified is that beyond the pure physical assets that come from these infrastructure-based industries, infrastructure managers usually have a role of coordinators of a system. They create a network out of scattered, fragmented pieces of infrastructure. Now, it's different in the different industries. Some of them have always been very fragmented. That's particularly the case in transport, for instance, in maritime, or even the most extreme example, which is road. In other industries, such fragmentation is not so relevant. Could be the example of water. And then there are industries which traditionally were more concentrated, but over the last years, due to different reasons, they have been increasingly fragmented due to technical reasons. And we can identify the case of electricity, where technology and new generation technologies have increased fragmentation in the generation of electricity. Then we can see that even the liberalization process that has been followed in many of these industries over the last decades has increased the number of players, and very often even the vertical separation of the infrastructure management and the service provided over the infrastructure. So there is more fragmentation. And digitalization basically allows to improve the coordination of all these fragmented ecosystems. And this is one of the key elements that we have identified. And better coordination of the pieces allows a more active role of the coordinator of the system. In terms, for instance, of even a more dynamic coordination of the systems. Just an example, if you go to aviation or to railways, usually timetables were defined months in advance and they were pretty much fixed. Now, thanks to technology, we can speed up this allocation of slots or tracks and make it far more dynamic. We can even think of, in terms of traffic management, on a real-time assignment of access to the infrastructure. So this is one of the more relevant changes introduced by digitalization. The big challenge is that, contrary to the reduction in cost on construction and maintenance, this more active infrastructure management will require an active participation of the different players in the industry. And the more fragmented, the more coordination will be necessary. So the benefits of digitalization will only be exhausted if there is very deep coordination. And coordination in the sense of data sharing, creation of data pools, new data governance schemes. So yes, a lot of data sharing, but we have to be careful. This is another finding, is that it's not only about data. I mean, data, as we were saying, is only a reflect of reality. Data sharing will only be powerful if there is a will or even an obligation to work together by sharing the data. So that might trigger even some regulatory intervention. And then, very important, if we have more active coordination of these ecosystems, what we might find out is that this coordination is not led by the traditional infrastructure manager, but that we have new players taking this role of coordinators of a system. That's something that we have started to see in telecoms, we have started to see in transport. It hasn't reached so many industries yet, but we can have the digital platforms substituting traditional infrastructure managers, not specifically in the management of the infrastructure, the construction and the maintenance of the infrastructure, but specifically in this role of coordinator of the system. At the end of the day, platforms can gather more data and they can get more efficient in the creation of network effects out of the coordination of all these pieces. And this could lead to very deep transformations of the infrastructure-based markets. And finally, this will be my last word, we have some specific challenges like the protection of privacy and very important cybersecurity. So the protection of critical infrastructure. So these are some of the key points and share points that we have identified across infrastructures. And now we will move to the presentation by the different authors. Not all the authors of the book will be present, but we have a fair share of them. We will follow the order of the book. The book, after the introductory chapter, starts with a chapter on technology. We have identified that there are common technologies across the different industries, and we thought that it would be a good idea to have an introductory chapter defining the infrastructures. And it was Professor Gunther Knips who developed this chapter. So please, Gunther, can you share your main conclusions, the ones in your chapter?
Thank you, Johan. Welcome, everybody. The goal of the chapter 2 on digitalization technologies is to characterize the role of information and communication technologies for the evolution of smart network industries. In the following, my focus is on digitalization technologies from the perspective of 5G. Among the few technologies uncontroversial characterized as general purpose technologies are included not only the steam engine and electricity, but also information and communication technologies. Whereas the first digital revolution generated a general purpose technology based on the innovations of microprocessors and digital computers, the second digital revolution saw the evolution of a general purpose technology of network computers based on all IP broadband communication networks. The upcoming generation of 5G technology can be considered as a next generation disruptive general purpose technology. 5G is spawning downstream innovation, not only for communication and entertainment, but also for a large variety of Internet of Things applications, so-called use cases of vertical industries, thereby becoming an essential driver for the future dynamics in smart network industries. In order to support a large variety of usage scenarios and applications, 5G entails demanding requirements for throughput capacity, so-called enhanced broadband, and critical communications, for example, low latency, high reliability, as well as requirements of massive Internet of Things, in particular large number of connections with low power, low cost. So the necessity for complementary combinations of throughput capacity, critical communications, and massive Internet of Things arises. This is partly due to the fact that throughput is not a substitute for quality of service traffic requirements. In particular, the over-provisioning of network capacity is not only economically inefficient, but cannot provide the required quality of service guarantees. Depending on the characteristics of heterogeneous application services, the complementary mix of all IP broadband infrastructures, including the appropriate frequency capacities, big data processing, and quality of service latency guarantees must be chosen. Digitalization in market for network services is fundamentally disrupting conventional network industries. In the meantime, platform-based services are becoming increasingly relevant, and there is an open and ever-expanding set of physical Internet of Things applications requiring operator platforms in their role as coordinators, aggregators, and organizers of smart physical network services. Operator platforms play an active role in the creation of new innovative markets for physical network services and complementary 5G-based virtual networks. The focus is on the governance of operator platforms driven by the requirements of Internet of Things applications and the future role of entrepreneurial decision-making within operator platforms. New challenges and requirements for a variety of heterogeneous operator platforms have arisen, combining the requirements of physical Internet of Things applications with complementary 5G-based virtual networks. There is a Burgundian literature about the growing number of use cases. They include automotive, medical, media and entertainment, manufacturing, logistic, agriculture, energy and utilities, and healthcare. In addition, 5G enables local dedicated industrial campus networks, such as Industry 4.0, smart, for example, smart manufacturing, smart agriculture, augmented maintenance, and safety monitoring. Entrepreneurs need to explore and exploit the innovational complementarities between upstream 5G networks and downstream application and use cases. In this perspective, local industrial networks are natural experiments of a competitive search process toward innovative solutions. The vertical cartography project provides a database of ongoing use cases, trials in different countries and industries. These reports provide numerous valuable details, but it is too early to conclusively assess success and failure of those ongoing projects. Thank you.
Thank you, Professor Nips. We will move now to the first of the industries, which is telecommunications. Telecommunications was the first industry to digitalize, and it's the basis for the digitalization of other industries. So it was the first industry to be covered in the book. So Volker, please.
Thank you very much. Thank you. First of all, thank you, Juan and Matthias, for the opportunity to be part of this great project and to speak today. It is my pleasure to give you a short pitch on the chapter I jointly wrote with Günter Knieps. Our chapter covers a lot of ground and comprehensively describes the digitalization and the transformation of the telecommunications industry into a highly dynamic and tremendously diverse broadband-centric ecosystem. Now, to set the stage, in stark contrast to other utilities or legacy telecommunication networks, where the provision of access to a dedicated purpose-built infrastructure can or could be more or less equated to granting access to a single or a small and rather static set of services, general purpose broadband platforms constitute platforms for innovation. They are not purpose-built, but rather support the delivery of an evolving and widening range of internet-based and non-internet-based content applications and use cases. This widening range of applications and use cases in turn causes dynamic, diverse, and complex demands for connectivity, for example, in terms of bandwidth and quality of service, as Günter mentioned, but also energy efficiency, mobility, security, and local computing. It has also given rise to complex allocation coordination problems. Now, how can the ecosystem deal with these demands? Let us first consider here what can be subsumed under the term topological innovations. So generally speaking, interconnection points and servers, and thus content, applications, and computing capabilities have strategically been distributed and moved closer to end users and devices. For example, a range of large cloud and content providers has deployed data centers and distributed server clusters at important hubs, for example, at internet exchange points where networks meet and exchange traffic. And also, and this is more recent, increasingly within the networks of internet service providers. So those providers that sell internet access to end users. These innovations reduce both the number of kilometers or miles and network borders data packets need to travel between communicating endpoints. They can improve performance and customer experience, as well as the ability to balance traffic loads and reduce coordination problems by cutting out middlemen. So this is a very, very important development, and much of today's internet traffic is already being exchanged, delivered from, or processed close to end users. In addition to this, there is a trend towards the privatization of infrastructures. So growing numbers of large cloud and content providers, for example, the so-called hyper giants like Google, Facebook, or Amazon, and others like internet exchange points, connectivity providers, and so on, they have built private backbone networks to connect strategically important locations like data centers or interconnection points via private physical or virtual links. So carrying traffic via their own proprietary networks abandons the need to utilize the shared capacities of the public internet. On the one hand, these networks enable purpose-built network design, provisioning, and management, reflecting a provider-specific service spectrum. They enhance functionality, performance, customer experience, and evolvability. On the other hand, they have caused a shift and the blurring of lines between the public internet and private networking. So this has substantial implications on the competitive and innovational dynamics in the respective public and private sphere. Finally, as Günther mentioned, 5G, or the 5G vision, I should say, is based on purpose-specific network slicing and virtual networks. Network slices combine local cloud capabilities based on edge computing resources and quality of service differentiated bandwidth capacities. They can be independently managed and flexibly customized to meet the heterogeneous and often stringent demands of an open set of applications and use cases. Let me finish my pitch with two takeaways. First, dynamic capacity sharing and the granular control and orchestration of complementary network resources become essential. They become essential to meet the complex and dynamically changing demands for traffic delivery on the one hand and local computing. This emphasizes the relevance and complementary role of local computing capabilities, as well as flexible and adaptive quality of service differentiations within networks. So in our chapter, we analyze corresponding differentiation strategies and show that economically efficient and incentive compatible solutions to those capacity allocation problems are based on pricing approaches that reflect the opportunity costs of different types of network capacity usage. It is thus important that regulations and public policies, such as network neutrality regulations, for example, do not unduly interfere with network evolution and the entrepreneurial search for economically efficient capacity allocations. A second takeaway is the conventional wisdom regarding telecommunications and the mental model of the internet must be reassessed. In today's ecosystem, service provisioning is based on a complex and evolving amalgam of both public and private, interconnected and complementary computing and communications network resources. Many of those are owned and managed by different and often competing entities. Some are open and shared, while others are dedicated or managed. So policymakers should acknowledge how ownership structures, hierarchies, and competitive and innovational dynamics have changed in an ecosystem that is increasingly fragmented and characterized by the localization of network traffic and network computing resources on the one hand, and a bifurcation between the public internet and private networking on the other. Thank you very much.
So thank you, Volker. I think telecoms shows the way, and I think it shows that the network management can become far more flexible than it was originally when the old public monopolies existed. So flexibility in the management of the infrastructure, I think, is the main lesson, at least for me. Now we move to transportation. We have two presentations. We will start with Anastasia presenting her chapter on the maritime transport. Anastasia, the floor is yours.
Thank you. Thanks for the introduction. But I will just say a few words about myself and my co-authors. My name is Anastasia Tsvetkova, and I'm a postdoctoral researcher at the Laboratory of Industrial Management at Åbo Academy University in Finland. And Finland is like an island with around 90% of its export and the import being transported by sea. So maritime transportation is kind of real strategic interest for the country and is also one of the strategic research profile areas at our university. So our laboratory has the experience in research related to sustainable shipping and various innovations in sea logistics and shipbuilding. Also, we have developed an expertise in industrial investments in different industries. So today I'm speaking here also on behalf of my two co-authors, Dr. Magnus Gustafsson and Professor Kim Wikström, and want to say that we are glad for the opportunity to contribute to this book and also to present our book chapter today. Well, first of all, what is maritime transport infrastructure? In our book chapter, we refer mostly to ports and fairways, but also vessels are actually could be considered as maritime infrastructure, even though kind of the logic of their construction is different compared to other infrastructure industries. But digitalization efforts kind of cannot overlook the solutions that are implemented on the vessels. As Juana was mentioning, some infrastructure industries are more fragmented than others, and maritime transportation is clearly one of the most fragmented chains. So for transporting cargo, you would usually need around 20 different actors involved, including different port actors, agents, port authorities, logistic providers, and ship operators, and customs, and so on. So because of this fragmentation, there is an incredible potential to make shipping more efficient, also environmentally. And that can be done through changing and improving the operations and coordination among the many actors involved. And digitalization naturally can play a crucial role in that. So we could say that there are three types of digital innovations and solutions related to maritime transportation, starting with the kind of basic digitization, which is still an issue in maritime transportation. So there is the need to reduce paperwork and communication among the many actors. So there are still kind of solutions discussed and being slowly implemented to solve this issue of paperwork and kind of physical communications. So these include, for example, single window systems for ports, where all the necessary documentation can be submitted digitally and then distributed to all the actors like customs or port authorities and port agents. But this is still kind of more business as usual, just making communication, reporting, and documentation easier and more streamlined. The second group of innovations relates more to the so-called smart infrastructure. So much more data is generated regarding the different infrastructures, and it can be used to optimize the operations. For example, we're talking about smart ships, smart ports, smart fairways, kind of smart everything. But such smart infrastructure can first of all, it can be used to kind of digitalized to be monitored and maintained in a more cost-efficient manner. For example, through creating digital twins of ports. Then it can be operated much more efficiently due to the increasing amount of data produced and analyzed. And also these different infrastructures kind of can talk and become part of the Internet of Things. So just one example on the smart ships, they can save fuel by around a third of overall consumption, usual consumption, through optimizing their voyage based on the data on how the vessel is loaded, the current weather conditions, streams, winds, and also the information about the traffic in the destination port. So the ship can choose an optimal route and avoid the harsh waves, for example, and then also spend more time sailing if it knows that there is like a queue in the port of destination. So then kind of there can be significant savings of fuel, which also has environmental benefits. Or then in a smart port, traffic and cargo flow monitoring and management can allow reducing the port area needed, which is often a problem for different cities. And prediction algorithms can be used to predict when vessels will arrive, and then also plan more efficiently the use of keys and loading equipment. And finally, as more and more data on smart infrastructure is available, and it's possible to connect it into the Internet of Things and achieve system benefits and network effects. So when we talk, for example, about autonomous shipping, it is not just about like one ship being completely automated and able to sail independently, but it's also an opportunity to organize logistics in a totally different manner. So far, maritime transport has remained a black box for the companies transporting their cargo. And the integration of data on maritime infrastructure in supply chain management and production planning could open up this black box and lead to different level of efficiencies and also enable new business models. In our chapter on maritime transport infrastructure, we review these different innovations, and also we discuss how they impact the transition of the business ecosystem around logistics, how the roles of the different actors change and which power struggles can appear, and also who will gain or lose from digitalization. So we are inviting you to get the book and read this chapter if you're interested. Thank you.
Thank you very much, Anastasia. So I take the point, the more fragmented an industry is, the larger the potential for digitalization to get efficiencies and also to transform the market structure. So we move now to the second transport industry, which is aviation. Lorenzo Casulo will be presenting on behalf of as an author and his co-author. So Lorenzo, please, the floor is yours.
Thank you very much, Juan. Indeed, I will be speaking about our chapter on aviation infrastructure and the potential for digitalization to transform aviation, not just the potential, but the reality in many aspects. The chapter was written by myself and my co-author Ivan Arnold, and he's a senior advisor at Hungaro Control. He has extensive experience in airspace management and ATM management. And on my side, I'm associate director at Ricardo Energy and Environment, a sustainability consultancy, where I work on sustainable and intelligent transport. So our chapter very much follows the narrative that you've heard from other authors. Until now, digitalization has a huge potential to increase efficiency, reduce costs, and improve the environmental performance of the aviation sector. The potential we are seeing in action in many aspects now, but in our chapter, we also elaborate on future possibilities of what we think digitalization can bring in the next 10 to 20 years. We think that whilst digitalization is a force of good in this sector, there are many risks that come with it. And we highlight these risks, unintended consequences potentially, and we put forward some ideas for regulatory actions that could be put forward to mitigate those risks. In our chapter, we look at the potential to address problems like fragmentation, again, congestion, environmental impacts. Those are all the problems that we know the aviation sector is suffering from and translate into poor performance. And digitalization solutions can act along those three problems: congestion, fragmentation, and environmental impacts, through better data collection, management, and use, through better integration of new players in a very fast-changing environment, and through more efficient operations and market structures, whereby digital solutions, they don't just change things at the margin, they really affect the shape of the market and the way that different players can enter the market and interact across the industry. So what do we cover in our chapter? In terms of digital innovations, the literature review covers services. So digital innovations in ticket distribution, for example, with the emergence and perhaps the fall of the global distribution systems. We cover vehicles with the automation of aircraft as the key thread around vehicles. We cover airports, so infrastructure in the real sense of what is normally imagined as aviation infrastructure. And we look at sensors, information provision, and the role of infrastructure managers at airports to innovate and to catalyze the potential of digital technologies. And finally, we look at airspace, which is the overarching infrastructure, and it's something we don't tend to see or think about, but it's what, from policy efforts, especially at the European level with the Single European Sky initiatives and then the Digital European Sky initiative recently, we are seeing holds probably the biggest potential to leverage AI, IoT, and data management applications. And the Florence School of Regulation is very active on these topics. So what we do in our chapter is only to touch briefly on an area that FSR is very active on. Then I think as a way of example, today in the short time allowed, I would like to highlight one of the interesting findings of our chapter, which is what is happening and what needs to be done with respect to the emergence of automated aircraft, i.e. drones in the common language of everyday life. Pilotless aircraft, which is a digital innovation in itself, because it starts bringing to life the concept of automated vehicles in the airspace, but it also affects the digitalization interaction with the airspace, with airports, and with telecommunication sectors, such as 5G, which has been talked about by previous speakers. So with the rise of drones, what we see is the emergence of the third era of aviation, as actually both Boeing and Airbus have defined in a recent paper. We see that there is a new technology, but also a new operating system. Where are the drones going to fly? This is the key question. Not in the ATM type in the airspace that is currently managed by traffic management, probably in somewhere below a U space that the European Commission is working on. And that U space to accommodate drones in itself needs to be automated and highly efficient at using digital innovations. So we see the disruption in one sector feeding into the disruption in another sector within the aviation industry. And we probably should see these examples scattered around the book as small pieces of a bigger jigsaw, which I would say for the first time the book brings together. And so when you read a chapter about aviation, like the one we have written, you start thinking about digital communication technologies like the wireless applications for drones and the 5G network. And you start joining these dots and really thinking about the benefits and, as I said at the beginning, the potential risks of the digitalization wave that the infrastructure sectors are seeing. So I invite you to read our chapter, and also I'm open for questions at the end of the presentation. Thank you.
Thank you, Lorenzo. So yeah, aviation shows how complex these industries can be and the different impacts of digitalization, from ticketing to ATM, so lots of different aspects. Now we move out from transport, we move to also to another very exciting industry where lots of changes are taking place and digitalization has a strong role to play. So we move to electricity. Nicolo Rosetto will be presenting the chapter.
Thank you, Juan. Electricity. I wrote this chapter together with Valerie Reif, and I also, I must confess, benefited a lot from feedback from the other authors of the book and also from some researchers at the Florence School of Regulation. What do we do in this chapter? Well, the message, I would say the main message are two. First, digitalization has been a kind of a buzzword in the electricity industry in the past 3 or 4 years, but actually it would be misleading to interpret it as a novelty. As you also mentioned, Juan, digitalization is a kind of process, and I would say it happened in waves in the electricity industry, and some of these waves are actually quite old now. They date back even to the 1970s and 1980s. But importantly, some waves now are becoming central, and I would say the core of it, it's the application of ICT, of digital technologies, to the distribution grid, to the appliances that are located in the premises of energy customers. This is really the frontier of digitalization of the electricity infrastructure. It's actually the frontier of many changes in the electricity industry nowadays. And some of these changes are actually have a very big disruptive potential, disruptive for the organization of the industry, disruptive for its regulation. This is the first message. The second message, and I would say goes together, is that digitalization is a fundamental enabler, and actually this is also in the title of our chapter, of the decentralization and a decarbonization of the electricity industry. This industry was very much concentrated and vertically integrated in the past. I would say this was easily explainable due to the significant interdependencies in the use of the common infrastructure, due to the capital intensity of these of many activities along this supply chain. But since I would say 30 years, we are seeing on the one end decentralization, so I would say an increasing fragmentation of the industry, with the unbundling of networks from generation and supply, and more recently by let's say the deployment of a huge number of smaller generation units. It's not only that we have a few big generators in the industry, but now we have thousands, tens of thousands of generation facilities everywhere in the electricity system, and many of them are very small. And the other is the decarbonization, the introduction of renewables. Some of these are intermittent. So these transformations
make the electricity industry more complex. They pose significant challenges. They run the risk of increasing significant costs for delivering electricity to final consumers, and actually undermine the reliability, the security of this of the electricity supply. Digitalization in this respect, digitalization of the electricity infrastructure, provides the tools to increase the coordination of these various actors, to increase the possibility to use all these resources, both the big and the small one, in a more efficient way. It allows to interact fast, to react fast to changes, and therefore is, as I said, a fundamental piece in the puzzle of the decarbonization and decentralization of the electricity industry. And this, you see, you have many examples of these. It can be from a dynamic rating of transmission lines. It can go to the algorithms needed to run wholesale electricity markets. It can go to your smart meter at your home. It can really take many, many examples. And I think that if later there's time, we can maybe dig a bit deeper in this one. So I would stop here. Thank you.
So thank you, Niccolò. And again, a very complex ecosystem and technology digitalization as a way to facilitate coordination of this complex ecosystem. Now we move to the last industry, which is water. Water is very different. Not so fragmented, so not such a complex ecosystem, but still, yeah, water infrastructure is also digitalizing. So Brenda, please, if you can present your main ideas.
Yes, of course. Thank you very much for the opportunity of collaborating with all of you for this book, and also for the opportunity of sharing some thoughts today. I'm Brenda Espinosa Praes. I'm a PhD researcher at Tilburg University, working at the department of, at the Tilburg Institute of Law and Technology and Society. And yeah, my chapter is on the digitalization of the drinking water sector. And indeed, I think one of the main drivers of digitalization in this sector is not so much the need for coordination of a fragmented system, but it's the fact that states around the globe need to ensure that drinking water remains available, of good quality and accessible in very challenging times, in times of a significant increase of the global population, times of climate change, and also in times of aging infrastructure. So basically, these challenges that are affecting the chances that that drinking water companies and governments have of ensuring that there will be enough water supply, and also on the other hand, the fact that every time there are more technologies available to gather more and improved information on how infrastructures are working and on the quality of water from source to tap, these are really the drivers behind digitalization in this sector. And in my chapter, I outlined a number of technologies that are used or that are representative of the digitalization in this sector. More importantly, the smart water meters, but there are also other technologies such as sensor networks, DMAs, the district meter areas, the use of data to create models and algorithms to predict how infrastructures will behave and when it will be necessary to replace them, and also to predict a demand of water, and also systems like SCADA, for instance. But today I really wanted to focus on one part of my chapter, which is actually the last part, which has to do with the role of regulations and other public policies in giving shape to digitalization in the drinking water sector. And first, I would like to note that compared to the other sectors that are discussed in the book, I would say that perhaps the drinking water sector is still one of the ones that is moving slower. And it could be related, or at least some authors report that this is related to the fact that the drinking water sector and drinking water utilities are usually very risk averse. And this is due to the fact that, yeah, there are like these public health and environmental concerns linked to the provision of drinking water. So let's say that there is one important factor that helps to the uptake of digitalization in the drinking water sector, and that's the support from the public sector. And this support can take different shapes by means of funding, for instance, but also by creating the, let's say, an appropriate regulatory environment for drinking water utilities to actually embrace the possibilities enabled by innovation, by digitalization, and also kind of like steering the use of these technologies in, let's say, in the right way, in a way that protects consumers, for instance. So in the chapter, I discuss a couple of examples of different types of regulatory or policy measures that can have a positive or a negative impact on digitalization, on the digitalization in this sector. So for instance, in terms of positive impact, we could distinguish between two types of measures that have a direct positive impact in the adoption of these technologies. So for instance, when governments explicitly mandate or encourage the adoption of smart water technologies, such as smart meters, for instance, and there is always the famous example of Malta, which had this like large scale rollout of smart water meters together with smart electricity meters. And maybe this is an interesting note, but let's say at least at European level, well, we have in the electricity sector much more clarity at EU level that smart meters should be adopted. This is not the case for the drinking water sector, for instance. So it's really pretty much left to the initiative of each of the member states, whether they want to move forward with this. But then we also have some measures that are less direct, that they're like indirectly helping to move towards digitalization. And it's when, instead of like prescribing the adoption of a specific technology, what states do is that they set certain targets or requirements that are easier to achieve when you make use of digital technologies, right? So for instance, one recent example is that there is the European Union Drinking Water Directive was recently revised at the end of last year, and that directive increased some requirements on water quality and on provision of information to consumers that are easier to fulfill or to comply with when you are making use of digital technologies. But regulations and the regulatory environment can also have a negative impact on the chances of digitalization to be adopted in a given context. And for instance, we have, as an example, I mentioned the original text of the European Drinking Water Directive, which the original text dates back to 1998. And that text, in a way, required that the samples that should be taken to monitor the quality of drinking water, basically that they had to be taken manually and at some specific points. And this was like really blocking the possibility of using remote sensing, for instance, to keep track of the water quality. And then in an indirect way, but also affecting the chances of adopting these types of technologies. There is one study that I found about the Dutch drinking water sector, where they have a regulatory instrument called the benchmark, which compares the performance of the different drinking water companies in the country and on different fronts, but still pays a lot of attention to the financial aspects and that these companies should be cost efficient. So these types of regulatory instruments indirectly prevent that companies can invest in innovation or that can test new technologies, because there is a lot of pressure to perform in a very cost efficient, but also in the short term, right? And just to conclude, then I explore in the chapter that while there is a lot of potential for smart technologies to contribute to a better management of drinking water infrastructure, of course, there are also challenges. As Juan mentioned, there are the challenges related to cybersecurity and the protection of privacy and personal data. I elaborate on these aspects in the chapter. And today I just wanted to focus on the importance of regulations and policies to stimulate and steer digitalization in the sector. And let's say to make possible that digitalization actually has a positive impact, would be important to revise the existing regulatory frameworks to assess if there is enough room for innovation, but also how they can address the challenges and risks that digitalization in the sector can create. Thank you very much.
Thank you, Brenda. So you made reference to some regulatory aspects, and most of the questions I have from the audience are on these regulatory aspects. I have one for Anastasia. It's about the role of regulation. For instance, you were underlining the opportunities in digitalizing port calling and the efficiencies in terms of speed, fuel consumption, and environmental impact. But the question is whether some kind of data sharing, data exchange would be it would be necessary to have it mandated by public authorities in order to make it effective, or whether the fragmented parties will coordinate on a voluntary basis among themselves. I mean, do you think some kind of data sharing obligation will be necessary to make it a reality, these efficiencies?
Thanks. That's a good question. So we also discuss it in the book chapter. It's probably more a bit of speculation because it's difficult to say how it will play out. But from the current experience, as I mentioned, there's still digitization that needs to happen, to many processes in there, and that has been usually led by some public authorities. For instance, European Union in kind of enforcing the single window or other kinds of common systems for the reporting. And when it comes to sharing the data on, I don't know, cargo and ship movement and schedules, I mean, some information is already publicly available. For instance, you can actually see all the ships where they are at every moment of time. There is this AIS, which identifies them, and that's kind of public information. But if you need something a bit more deeper, it seems there will be challenges to kind of get the actors cooperate. And it seems like the kind of biggest progress is usually made when there is already some kind of vertical integration. For instance, a company that owns the port and the vessel and even land logistics is controlled somehow. So then data sharing is easier, and there are already some kind of solutions implemented. Examples could be Amazon or this kind of giants, who can afford this. But yes, it might be that some kind of action from policymakers would be required, but it could be also that there will be some front runners who can kind of show the value of sharing this data. At least we're hopeful.
Thank you. I have a question for you, Volker, which is basically the contrary. I mean, you were referring that regulatory intervention is rather a threat. I guess you were referring to the net neutrality regulation, and which somehow is an obstacle to more managed coordination of the infrastructure. Do you think there is a role for some kind of positive public intervention regulation, or?
Well, if I understand your question correctly, so first of all, I wouldn't say it's a threat per se, but I think one needs to recognize that if specific incentives to differentiate, for example, change, and the reference point, for example, for a regulation or an intervention is a bit backward oriented, we need to make sure that we adapt the regulatory framework to the current, state of the ecosystem. This is the most important thing, that you do not stifle, for example, regulation. And we see this sort of I wouldn't say a collision course, but you see a sort of tension between the idea of network slicing and 5G networks and network neutrality. So this is, but there's still a sort of a sort of loophole kind of thing where you can, it's called specialized services. If it's not labeled as internet traffic, it's not subject to the same regulation. So there is scope of to innovate in that respect. But Of course, it's perhaps a fine line to what extent you create some regulatory uncertainty in which garden you are considered, or whether you are subject to the regulations or not, and whether this affects, for example, or negatively affects network evolution.
Okay, thank you. And then I have a question for you, Nicolo, always on these regulatory angles. Again, very fragmented ecosystem, lots of players. What type of data sharing, data governance do you see evolving? It's rather a bilateral relationship, data sharing. Do you see the creation of some kind of data pool? Maybe these energy data spaces that are being proposed by the Commission. I mean, how do you think that this data sharing could take place in the electricity industry?
It's an interesting question, Juan, and probably my co-author would actually have a very even more detailed answer. But my general view on it is that the answer much depends on which data, because we need to distinguish if we are talking about, for instance, consumer data or data about the network, data about, let's say, wholesale actors. And this actually goes back to what I said earlier, that digitalization comes in waves in the electricity industry. At the, let's say, transmission level, at the level of wholesale markets, the digitalization, the importance of data, the access to data, it was an issue already some years ago. And now we have, I would say, a quite developed framework in countries like, like in the European Union, but also I would say very similar in the US or in Great Britain, where there are platforms that collect data on transmission networks. There are platforms that collect data on wholesale markets and make them available to basically everybody. So in this regard, there is already a well-developed governance. There are already rules that support the harmonization, let's say, of data, their collection and their availability to all the market players in the industry in order to streamline operation of the system, operation of the market, and so on. On the contrary, when we talk about data on the distribution grids, so the grids that bring electricity directly to the houses or to the factories, to the final consumers, and data on final consumers, the situation is less developed and actually became an important topic of discussion only in the past few years. Earlier, it was mostly something of interest for the distributor company and for the supplier of the individual customer, but there was not much more to do with it than billing, often in a rather dumb way, the final customer. Now, those type of data are more and more interesting because, as I said, really the frontier of change is at the distribution level, is at the retail level. New business models are emerging there, new value propositions are appearing. One, for instance, are flexibility, local markets for flexibility, or energy as a service, where you do not sell any more kilowatt hour to final customers, but you sell more sophisticated products or services, exactly. And this, of course, requires access to data, requires a kind of standardization of the way in which data are collected, are stored. And so I would say on this regard, there is much more to do. And I would say that the European regulators, for instance, are really discussing this kind of topics. And these topics will probably also end up in the discussion on digital spaces, including energy. I don't know if I answered your question.
Yes, very well. Gunther, I think you wanted to raise some comment on privacy and cybersecurity. We cannot hear you. You are muted.
Outline.
We can hear you now. Go ahead.
Yes, it continues to the point what Nicolo had. What kind of data? When you have data which you need, for example, when you have connected vehicle, you have sensor networks, which camera-based sensor networks, which are working together from different vehicles, bring this data into the platform so that the whole system can function. Then this data should not be confidential in the sense you have to lay open this data, but in contrast, what kind of electricity you use at what time of the day and how much you use, that is not necessary for the functioning of the network. When you have a low voltage network, it doesn't matter where you are in this local environment. And when you shift the level of electricity, because you have too little electricity in a movement to take something from the distribution network, you need only the aggregated data and not the individual data. So that I think this kind of requirements when to lay down, to open the data on the individual level, and when you aggregate the data, that has to do, I think, also with privacy rules and data protection rules. And that is my question. Do you think that more has to be done in this kind of rulings in the data protection and also including cybersecurity aspects? Or do you think that it needs only a better experience and learning process how to apply the given rules we have already today?
It's a question for me, Gunther. You're right that there is usually this trade-off between letting everybody having access to data, sometimes with personal data, and on the other hand, restricting this access. I cannot, let's say, provide you the ultimate word on this. Valerie actually would have done much better, but there is awareness of this trade-off. There is awareness that privacy is important and data should be, where possible, provided in an aggregate way or anonymized. However, I must also say, Gunther, that new business models really rely on very granular access to very granular data. You probably refer to a context in which, for instance, distribution grids had no constraint or could be thought as a copper plate. In this case, it's not really much important when you consume. But with the development, for instance, of flexibility platforms to provide flexibility to solve local constraints, this assumption of a copper plate may no more hold true. And so actually there could be a value in having access to very granular data, also on customer data. And this, of course, is tricky. This raises the issue of privacy. Of course, a kind of balance should be struck between these two, let's say, interests. On the one hand, the privacy for consumer. On the other, let's say, the raw material upon which new actors can build new services that actually benefit the system. Because again, in the context of decarbonization, a massive penetration of distributed generation, electrification of end uses, the use of networks is becoming more and more volatile. Congestions become more and more frequent. You cannot build networks that are able to host any kind of load patterns. And then there is a space for active management of users and the same networks. And this requires the data.
Thank you. We close the Q&A now, and we go to the concluding remarks by Professor Finger, co-editor of the book and director of the Florence School of Regulation Transport chapter. So the floor is yours, Matthias.
Thank you. You can hear me?
Yes.
Okay, good. Thank you, Juan. Thank you all for contributing to our book. It was it was an interesting exercise. You know, an edited book is always an interesting exercise, even though we had given a template. You know, all of you write from very different perspectives. But I think at the end, you know, there is a lot of coherence in this. And what I'm trying to do in this conclusion is not show everything, but I focus around the question of efficiency. I mean, the question is, what does digitalization do to infrastructure, bring to infrastructures? And we wanted to look across the different sectors. I'll try to make a synthesis around, and this is what we wrote up in the concluding chapter, you know, around the question of efficiency, but we could do other things. It's not exhaustive. You know, we could have looked at security, at quality, at privacy, you know, but still, I think efficiency is, at least for the beginning, for a start, a very good way of comparing. And so I'm just putting up, I will not comment in detail, but I'm just putting up the table that that we have put into the conclusion. And you know, and we can discuss all these X's, whether they are placed right. And I don't want to do that. I want to do, you know, I want to explain the dimensions of efficiency. And, you know, and basically we came to this, you know, by reading through your chapters and then gradually building up these dimensions. You may not have used the same words, but I'm putting it. So the first, I think most obvious, I mean, obviously it's all about coordination of fragmented value chain systems. So the first one is, you know, efficiency, and we think we see it. I mean, Anastasia talked about the shipping, but you can see it in mostly in transport, logistics. Christian is not here on the postal sector, but I call this end-to-end efficiency. You can, thanks to digitalization, somebody said eliminate the middleman. You can look at the entire supply chain and you can optimize, make the supply chain more efficient. I think that's that's at least a first type of issue, or we call it logistics efficiency, if you want. Postal DHL is very good in optimizing the whole thing. So I think we see that in most of the network industries, and maybe I could even put X's in electricity and all that, making that kind of efficiency. I think and that's pretty banal. It's not that, you know, sophisticated, but it is worth saying that this is one of the consequences of digitalization. Okay? Then the next three pertain to the fact that infrastructures, network industries are systems, complex, dynamic systems, socio-technical systems. And the first one, system efficiency one, or what I call the vertical efficiency, actually, it was also said, stems from the fact that originally that we have unbundled these systems. We have fragmented, mostly in the context of liberalization, you know, separating the infrastructure from the services on top of the infrastructure. We have unbundled, fragmented, and thanks to, and lost some efficiency in the process. We have created competition instead. But I think thanks to digitalization, we can now have both. We can have unbundling and we can have the efficiency back that comes from the vertical integration. But I think here we can even add, it was said in the context of electricity, for example, you know, decentralized generation. Digitalization leads to a lot of decentralized operations and coordinating all that, I think, thanks to digitalization, brings vertical efficiency. Horizontal efficiency, I see it more, this is more on the jurisdictional, political, institutional side. You know, these systems have, air is a good example, where when you talked about you know, air traffic control, which is, as you said, is one of the big things that we are doing in Florence. You know, these fragmented airspace managements, digitalization as a way of connecting the different national jurisdictions for all these infrastructures. I call it horizontal, maybe it's not a good word, but it's really, you know, we're, especially in the context of Europe, but air is global, we have the possibility to coordinate thanks to digitalization horizontally much better. And the third one, I struggled a little bit with the term deep efficiency, but I think it reflects well. This is really, I put it there in electricity, and Brenda, maybe in water, you didn't talk about it, but I think I see it there too. You know, to actively involve the users into the governance, into the coordination process. So in electricity, we call this demand side management. Smart meters, it goes much deeper into the behavior of the users thanks to digitalization. And that adds yet another layer of efficiency. And I think this is sort of a way to synthesize a little bit what you all have contributed to. It's work in progress. I'm sure we can improve this still somehow, but you know, to conclude, you know, I think we could discuss about where we go from here. You know, of course, this is a little bit, this table here is a little bit idealistic. Of course, end-to-end efficiency is not yet fully functioning. Neither is vertical, neither is horizontal. Single European sky is still not there. You know, all these smart metering and connecting all these things is so there are obstacles to this. And I think in the next book or in the next project, I think of our group, we could go a little bit deeper and what exactly are the obstacles? Technical, standards, organizational, ownership, different companies with different strategies, proprietary things, jurisdictional simply, terminology, definitions of things. So I think better identify the obstacles to these efficiencies and then, you know, remedies to overcome them. And we talked a little bit already in the Q&A about regulatory answers. There is also the question of what can be voluntary and what needs to be regulated. But maybe there are also technological answers, you know, that can somehow facilitate the overcoming of these obstacles. So I think that's a little bit for the future. But what I wanted to do here in conclusion, thanks to your contributions, was to somehow put it at least under the aspect of efficiency, put it together. So thanks again to all of you, and back to you, Juan.
Thank you, Matthias, for the concluding remarks and these ideas on the different types of coordinations and efficiencies. Thank you to the authors that have presented today, but also the ones that are not present that have contributed to the book. And thank you to the audience. I think it's time to close this event. We have recorded it, we will upload it, so we will be able to reach a wider audience. And well, this is just the beginning. I mean, the digitalization is a process, and there is way to go in this process. So we will keep studying it. So thank you very much and have a nice day.
Thanks to you. Have a nice day.
Thank you. It was very efficient.
Thank you. Have a good day. Bye-bye.
Have a good day.